Measured around 3 corners. The slide rule in geodesy. As one of the fundamental fields of mathematics, geometry was historically closely linked to the art of surveying. Also known today as lower geodesy, land surveying was initially concerned with measuring areas, distances, and heights, as well as mapping the Earth's surface. As a result, scholars developed all kinds of tools and instruments to simplify the necessary measurements and calculations. Land surveying has been an integral part of most cultures since the beginning of recorded history. The ancient Egyptians, for example, used simple instruments such as the 12-knot cord and the murchid, a measuring instrument made out of wooden strips and cords with weights. This was used to remeasure the fields every year after the Nile flooded. The near-perfect perpendicularity and alignment of the Great Pyramid of Giza also underline the skills of Egyptian field surveying. For the Romans, land surveying was essential for the division and administration of their vast empire. They developed the groma, a measuring instrument for marking out right angles, consisting of a tripod and a rotating, right-angled axial cross with hanging plumb bobs attached to it. The tasks of the Roman surveyors, also known as grammatici or more commonly mensures, were the construction of legionary camps and settlements, as well as the planning of viaducts and roads. Although geometry was considered one of the 7 liberal arts in the Middle Ages, surveying technology suffered from severe simplifications during this time. While some Roman measuring instruments were still used, precise measurements and mapping were mostly dispensed with, relying instead on empirical values, more or less detailed directions, and imprecise units of measurement, such as ell, foot, and step. In the Renaissance, also known as the Age of Discovery, more accurate maps and surveys were needed, which is why scholars developed numerous measuring and calculating instruments for land surveying. The slide rule was one of the most versatile instruments and was used as a calculation aid in land surveying between the 17th and 20th centuries. The function of the slide rule is based on the use of logarithms. It consists of the rule, the slide, and the cursor. The slide rule can be used to multiply by adding distances, while subtracting distances with the slide rule corresponds to division. The Englishman Edmund Gunter first came up with the idea of transferring logarithms onto arithmetic rules in order to simplify arithmetic. He described his Gunter's rule in 1623 in his work The Description and Use of the Sector, Crossstaff and Other Instruments. In it, he also described his version of a well-known measuring instrument, the crossstaff. The crossstaff has been a common tool for measuring angles and distances since ancient times. It generally consists of a base rod and one or more cross pieces with readable scales. Gunter's staff was the first to have logarithmic scales, which made a wide range of surveying applications possible by using a pair of dividers. Unfortunately, both Gunter's rule and the crossstaff he described have not been preserved for posterity. However, the idea was taken up again a few years later by Robert Bisseker. Bisseker's slide rule is considered to be the oldest surviving slide rule in the world. The logarithmic and measuring scales were applied to 4 movable slides enclosed in a wooden body. This slide rule was originally part of a combined instrument, consisting of a crossstaff and a slide rule, and thus unified the measuring instrument and calculating aid required for land surveying in one device. But how were these instruments used for land surveying? Measuring instruments such as the crossstaff initially provide a series of measurements that are then used to calculate unknown variables, such as distance or height, which are required when creating maps or plans. The calculation of the desired variables required the use of some angle functions, the values of which usually had to be read off special trigonometric tables before the final result could be determined using the slide rule. One of the most famous personalities in geodesy was the mathematician Carl Friedrich Gauss. In addition to mathematics, Gauss also devoted himself to the fields of astronomy and geodesy, which is why he was commissioned to carry out the survey of the Kingdom of Hanover in 1820. This Gaussian survey, which was carried out using the principle of triangulation, lasted until 1826. Triangulation is the division of an area into a triangular grid and the subsequent measurements of the triangles. To do this, Gauss first arranged the placement of several triangle points, which were used to measure angles. Starting from an exactly measured original triangle, further distances or edge lengths could then be calculated. Triangulation takes advantage of the fact that at greater distances, angles are easier to measure than distances. The previously mentioned trigonometric formulas can then be used to determine relationships between angles and sides. In the process of these triangulations, Gauss also invented his own measuring instrument, the heliotrope, which was depicted together with a triangulation grid on the back of the 10 D-Mark bill. While Gauss succeeded in significantly increasing the accuracy of the land survey, it was still a lengthy and laborious process, not least because the trigonometric functions required for the calculations still had to be read off tables. In order to simplify the use of these trigonometric formulas, slide rules with special scales for these expressions were produced a few years later. Named after the quick measuring method of tachymetry, tachymetric slide rules were used by surveyors and cartographers for fieldwork to create a map of the surrounding area in a short time. Two applications illustrate exactly how such a tachymetric slide rule was used for land surveying. For example, to calculate the distance between Siegburg and Cologne using triangulation, we use the distance between the tower of Siegburg Abbey and the chapel on the Michelsberg in the Eifel region, which is known from another triangulation. The required gamma and beta angles can also be determined from two measuring points using a graphometer. Using the sine function, the distance between Siegburg and Cologne can now be easily calculated without having to measure it, which would have been very time-consuming and inaccurate over long distances. Heights such as that of the Drachenfels, which cannot be easily measured, can also be calculated relatively easily using the tachymetric slide rule. For this purpose, triangles are also used in order to calculate the height using the angles of a triangle. If the distance d from the measuring point to the center of the mountain is known, the height h of the Drachenfels can be easily calculated using the tangent, the value d, and the measured angle alpha. While tachymetric slide rules were used by geodesists in the field until the 20th century due to their portability, they were soon replaced by mechanical calculating machines at the desk. Calculating machines, such as the Mercedes Gauss, which was named after the famous mathematician, were developed in close cooperation with geodesists. And special twin calculating machines, such as the Thales Geo, were particularly suitable for surveying tasks, for example coordinate transformations. Today, geodesists use the latest technologies to measure the Earth. Lasers, satellites, and radio astronomy enable us to measure much more accurately and quickly than in the days of Gauss and slide rules. Nevertheless, slide rules were an important milestone in the history of geodesy due to the use of trigonometric scales and their ease of use, and played a key role in measuring the world.